Hi, Phil Whitehead here again, and welcome to video number 5. In this one, we're going to get real world. We're actually going to take a case study. I can't really divulge the name of the client on this, but you'll see how we applied the principles that you've learned in videos 3 and 4 to a real world case study, and it's a very complex system. As a matter of fact, it's one of the more complex systems that we've actually studied. So I want to go through this briefly with you. I'm not going to take you through all the detail, but I'm going to give you an idea of the power behind modeling and simulation modeling, specifically to very real world and very, very complex systems. And the insights that the management team was able to gain from this model, or these series of models, was phenomenal. And you'll see those at the end of this presentation as we go through the results. And I think you'll be amazed. See you on the other side.
Okay, let's jump into this case study. This case study represents a manufacturing system that had been in existence for over 100 years. As a matter of fact, for a particular product line, it was a mainstay of the business and therefore critical to the success of the business. The organization was facing quite a bit of change, and both at the operational, organizational, and technological areas of the process. So here's kind of the summary of the challenges that they were facing. They had new demand rules. They had to move immediately from make to stock to make to order. This was a corporate edict. They had been postponing it because of all the changes, but they had run out of time. They were forced to implement a new automated planning system, a constraint-based planning system that totally flipped upside down 100 years worth of culture on how the planning was done. Basically, have a hunch, make a bunch, as you'll see in a few minutes. So they had to move away from that, implement a new planning system, and oh, by the way, they had to move a distribution from off-site to a remote location, and on top of all that, they had to shut down a keystone manufacturing process for an extended period of time for maintenance and upgrade. Other than that, they faced no challenges. And I will tell you, rather than make these changes, they struggled for a number of years prior to our organization arriving on the scene. They were just flat out of options, out of times, and out of ideas. And so we came in with a simulation idea under extreme time pressures for results. And even with all of that, we still face the challenges of change and change management as we went through this process, convincing management, not the employees, but management, that this was the right thing to do, which they ultimately bought into. So there was a lot of challenges, but let's look at their unsynchronized manufacturing system. They had one primary machine that started the whole process, called a polymizer, and it generated the raw material and different types of raw material for all the processes to follow. When we first started this, they were running off of an annual schedule. Now think about that. They had to forecast 1 year in advance the product mix. That was a challenge. And with lots of buffer inventory, lots of changeover time, just every imaginable hurdle that you can imagine. These fed various other secondary processes. For example, the coder. The product had to go through a coder. But that's okay, because it had a 7-day shelf life, or 5 to 8 days shelf life. But that's okay. They had 20 to 30 days worth of inventory. Not a problem. So they were generating a lot of scrap with this forecasting methodology that they were using and running the polymizer the way they were running it. Very, very inefficient. And they just flat didn't see it. They just thought that scrap was the norm. It was the way you did things. And then we had a cutter operation and a slitting operation. That in turn fed various processes that were sales order driven to basically convert the material to a usable format. So a sales order would come in, they would run through a conversion process, and away we go. So they had something like 7 conversion lines and 50 product families and so on and so forth. So it was quite the complex system. So the way this happened is when a sales order came in and there was nothing available on the line at that point, they looked in their work in process buffer inventory. If nothing was there, they went to the next operation back to look in that buffer inventory for the material that they needed. So they were all the time robbing Peter to pay Paul, which was just totally disruptive to the scheduling process. And it's a wonder that they satisfied any customer demand whatsoever. So, but that was the way they had done things for decades, and they were used to it, and they thought it was okay. So this is the environment that we walked into. And by the way, we've greatly simplified this operation. There was well over 150 separate manufacturing operations within this one single facility. So there was a lot of moving pieces here. And we had to accomplish this whole mission of identifying the changes to be made and coming up with a plan to make them in about 3.5 months, which we did accomplish. So how did we do it? We developed a suite of simulation models and decision support protocol that would show the plant managers how to achieve the synchronous flow of its manufacturing operations. So we had to demonstrate this. That's a key component of simulation. You can actually visualize the operations working. We converted the system from make to stock to make to order flow type situation in the future state models. We had to simplify the implementation of its automated planning systems. As you recall, all that buffer inventory and inefficiencies would have made the planning not any better, but that's okay. The technology was faster, so they would do the wrong thing faster. That was basically the bottom line. So we had to simplify this planning system. We had to make sure that it was linked into the manufacturing system at key points, key constraints. And so this is kind of what we came up with at the end of about 3 months, with a lot of late nights and etc. With the team. Again, we had the polymizer and the secondary ops. We had reduced the scrap by the scheduling system. We had identified one entry point for the customer orders rather than by machine, if you remember it before. And we were able to go all the way back to the polymer and pull out of this buffer inventory the material that they needed just in time. So that material flow was greatly simplified, and it was geared directly to the customer requirements, not some sort of silly intermediate forecast. The summary of the results, the major results were a 4 million annual increase in profits, which has not been adjusted for inflation. That would be closer to probably 12 or 15 million nowadays. In today's dollars, a 30% increase in throughput, a 60% reduction in cycle time, a 70% decrease in the inventory. And by the way, the whole thing from the start of our project to the implementation of and started seeing the results you saw was less than 6 months. So our conclusions were the success or failure of an enterprise depends on how well its total business system works. It must be synchronized with the marketplace. To implement a total systems approach, a business must be viewed as a system, as an integrated collection of processes, and they must be synchronized in order to work properly or efficiently. And we can use simulation modeling to facilitate that whole process of understanding, making the adjustments, identifying the changes, and implementing those changes in a far more risk-free environment and speedy manner. So this kind of concludes the simulation piece. The next video we'll go through the actual methodology of building a simulation model, and then that will be followed by the last video or planned video in this series, where we will talk about some of the implementation issues associated with data collection. See you on the other side.